In this video, we are going to solve rational inequalities. So remember from polynomial inequalities that solving an inequality means finding the interval or intervals of the domain that satisfy the inequality. We can use a graph to solve. I should have said that this is equal to f of x. So when is this graph less than -2? If I draw the line y equals -2, I can see that only this part of the graph is less than -2. So from about 0.8 to maybe 0.9. So a quick solution, but an approximate one. So let's see how we can solve algebraically. So this form, we see we have a factored rational inequality compared to 0. And remember when we had inequalities with polynomials, we had two options to figure out. Well, it's easy to find when this equals 0. It's just at our x-intercepts of -1/2 and 4/3. But it's not as easy to figure out when this is greater than 0. So we either have to sketch it or do a factor sign table. And I definitely think factor sign is easier in this case because sketching it requires a number of steps. So a function can change between positive or negative at an x-intercept, but also at a VA. And there's a VA here at -3. So these three numbers will cut up our domain and create our intervals. So everything less than -3, from -3 to -1/2, -1/2 to 4/3, and everything greater than 4/3. Now put every single part of your function in the table. So we have a negative sign, we have 2x plus 1, we have a 3x minus 4, and we have a x plus 3 all squared. And then we need a final row in the table. This is overall our quotient. So this negative sign only ever contributes a negative, and x plus 3 squared only ever contributes a positive. 2x plus 1 for x less than 3 is negative. For x of -1 is also negative. But for x is greater than 1/2, it's positive. And 3x minus 4 is negative until x is greater than 4/3. So overall, this function is negative, then positive, then negative. And we are looking for when is it greater than 0, and also when is it equal to 0 at those 2 points as well. So we will say that it is greater than 0 from -1/2 to 4/3. Great, and that's all we worry about, because at -3 it doesn't exist, so that's not part of the solution. So we've got both zeros for it to be equal to, and between those zeros, that is when the function's positive. Okay, so what if it doesn't already equal 0? We're going to have to manipulate it. So first we will note any restrictions on the variable. X can't be -1. We will rearrange the inequality so one side is 0. So we can't get rid of the fractions with inequalities because sometimes what you would be multiplying by, like the factor you'd multiply by, will be less than 0, and sometimes it'll be greater than 0, and we wouldn't know what to do about this inequality sign. So instead of getting rid of the fractions, we're going to combine expressions using a lowest common denominator, and then we'll simplify and factor. So x plus 1 is our common denominator. X plus 4 already has it, and this minus x needs to be multiplied by it. Good, so now we have one expression. Then we're going to simplify and factor. So I will multiply by -x And then I will clean up negative x squared. My x's cancel, plus 4 over x plus 1 is less than 0. I'm going to factor out a negative sign. Okay, now my favorite thing to do with negatives is actually divide them out. But in this case, that will change the sign to greater than 0. And I will continue factoring x plus 2, x minus 2 over x plus 1 greater than 0. All right, so what did we have? We have our x-intercepts at x equals plus or minus 2. And we have our VA, well, it's a restriction, but it is a VA. You can call it a VA or a restriction at x equals minus 1. So I'm going to make a quick table for everything less than negative 2, from negative 2 to negative 1, from negative 1 to 2, and greater than 2. Using my most simplified expression, I have x plus 2, x plus 1, x minus 2. So note, and I love to do this, is I love to order my factors in the order that they create the zeros. So x plus 2 makes minus 2, x plus 1 gave us an x-intercept of minus 1, and x minus 2 gives us our final x-intercept. Except minus 1 was a vertical asymptote. But anyway, so everything less than 2, all of these will be negative. Between negative 2 and 1, like negative 1.5, it's positive, and the rest are negative. Between negative 1 and 2, like 0, we have 2 positives and a negative. And when it's greater than 2, all of these expressions are positive. So overall, we have negative, positive, negative, positive. And we want to find when is this greater than 0. Whoops, greater than 0. So my intervals are from negative 2 to negative 1 and 2 until infinity. Great, let's do one more. All right, so our restrictions are negative 1 and 3. We have to move one side over. So the other side is 0. Our common denominator will be the product of these. So x plus 3 must be multiplied by x minus 3. And then we'll have minus x minus 2 multiplied by x plus 1 will be greater than or equal to 0. So I've done steps 1 and 2 and halfway through 3, and I'm going to have to simplify and factor. So I'll start by foiling out my brackets, x squared minus 9 minus, and I'm going to just do this FOIL but in brackets. So x squared minus x minus 2. All of this is over, x plus 1, x minus 3 greater than or equal to 0. So I'll have x squared minus x squared. I'll have x minus 7 over x plus 1, x minus 3 greater than or equal to 0. All right, so to analyze this, the x-intercept is 7. We have VAs at x equals negative 1 and 3. So our table will be formed by everything less than negative 1, between negative 1 and 3, between 3 and 7, and everything greater than 7. So again, I'm going to line up my factors, x plus 1, x minus 3, x minus 7. Okay, for everything less than 1, this is all negative. Between less than negative 1, sorry. Between negative 1 and 3, like 0, positive, negative, negative. A number like 4 is between 3 and 7, so these are positive, but that's still negative, and everything greater than 7. All the functions will be positive, making our function go from negative to positive, from negative to positive. And I'm looking for, just go back to my most recent one, when is this greater than or equal to 0? So here's when it's greater than 0, and remember this is where it is equal to 0. So for my interval, I'm going to have from -1 to 3. Those are round brackets because the -1 and 3 are actually restricted. Oh, not plus, u. So my last bracket is everything greater than 7, but x can equal 7, so 7 to infinity. So as a little reminder, restrictions are never included, whether it's equal to 0 or greater than or equal to 0 or less than or equal to 0. Restrictions are never included in the solution set. But 7, 0 is, and that's because x equals 7 is an x-intercept. Okay, so always lots of little details. It's always very fun. Do all the homework because the little details change every time, and I hope it goes well.